Lesson 5 of Chapter 5 deals with coordinate geometry. And the key thing we're going to learn in this section is slope. So slope is a number, usually a fraction, that measures how steep a line is. And that fraction is obtained by figuring out the vertical change between 2 points and putting it over top of the horizontal change between 2 points. The much simpler version is rise over run. When we do this, we are always going to, on whatever line we're doing, go from the point further left to the point further to the right. What this will do is it will let rise be positive or negative. Positive if we go up, negative if we drop. But run will always be positive because we're always moving to the right. The reason we do this is so we don't have to worry about dealing with positive, positive, or negative, negative. Positive and negative is determined by did you go up or down. If we always go to the right, then that's all we got to worry about. I'll deal with this a little bit next here with the parallel and perpendicular lines after we do the slopes. So this diagram, which hint, hint, wink, wink, nudge, nudge, you're going to see again, possibly on a graded test type thing, has 6 lines on it. And we're going to figure out the slope of all 6. Now, this bit's going to be a little strange, but when we represent slope with a single letter, we use M. I'm not entirely sure why that is. Probably has something to do with Arabic languages or possibly Latin. Something that when this was figured out, the word they used to describe slope probably started with something that sounded like M. So it's been convention for a long, long time. We can't change it. Slope is represented with the letter M. So I'm going to find the slope of 6 different lines. So I need some way of remembering which is which. Easiest way to do that is to include a subscript to the M for slope. So for example, there's line PA. There is a line XY. There is a line GH. There's a line PQ. There's a line RS. And there is a line AB. Subscripts like this let you identify which line you are finding the slope of. So now, I'm going to start with PA. So PA is this line. And I'm going from P to A. So to get from P to A, I go down 1, 2, 3. So down 3 is -3. That's my rise. That's the top number. The run is the number on the bottom. Turn and go to the right, 1, 2, 3. Our run is 3. So we've got -3 over 3. That means the slope of line PA is -1. Line XY is this long boy. So to get from X to Y, I have to start by going down 1, 2, 3, 4, 5, 6, 7. So down 7. Then we turn and go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. -7 over 9. That fraction doesn't simplify. So that is the slope of that line. Line GH lies here. And to get from G to H, we have to go down 1, 2, 3, 4. So down 4. And then we turn and go right 1, 2, 3, 4, 5. So the slope of GH is -4/5. Now we're going to go to the uphill lines, starting with PQ. To get from P to Q, I have to go up 1, 2, 3, 4. So that's a positive 4. Turn and go right 1, 2, 3. So that's positive 4/3. For line RS. To get from R to S, I go up 1, 2, 3, 4, 5. I turn and go right 1, 2, 3, 4. And finally, for line AB, from A to B, I go up 1, 2, 3, 4. And I turn and go right 1, 2, 3. So there we figured out our slopes. Now we're asked to identify parallel and perpendicular lines. So, parallel lines have the same slope. So are there any lines here that have identical slopes, the exact same number? Yes. Lines AB and PQ have the same number. So AB is parallel to PQ. These are lines, so we do need to put the line symbol above them. Line AB is parallel to line PQ. That's it for ones that are the same. Perpendicular lines have slopes that are negative reciprocals. What that means, okay, so negative means different sign, and reciprocal means flipped fraction. So are there any fractions here that are flipped where they have different signs? And I hope you're seeing that negative 4/5 and positive 5/4 fit that description. That means that line GH is perpendicular to line RS. Okay. This double L, by the way, is a parallel symbol. The upside down T is the perpendicular symbol. You can write out is parallel to and is perpendicular to if you really want to. I personally don't want to. So there we go. Finding slopes and identifying parallel and perpendicular lines. Next, we are going to graph some quadrilaterals and give all of the names that apply to the quadrilateral. So this is a bit of a process. You need to pay attention so you know what you're doing. First, we have to plot all these points. So J is at negative 6, 3. That means left 6, up 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3. That could be a little bigger. Let me get a bigger dot here. There we go. And that is J. K is at negative 2, positive 3. That's K. L is at, negative 2, positive 3 is not there. Negative 2, positive 3 is over here. It's left 2, up 3. L is at negative 2, negative 1, which is left 2, down 1. And M is at negative 6, negative 1, which is left 6, down 1. Here we have ourselves a four-sided shape. And I'm actually going to do the edges here in highlighter. It'd be easier to see that way, I think. Now, this is going to be the part that most of you don't like. I am going to require you on these kinds of diagrams to write the slope of every line segment. The slope of JK is, well, we don't rise, but we run 4. So it's 0 over 4. That's 0. ML is the same thing. We don't rise, but we run, so that's 0. The other two lines are vertical. By definition, vertical lines have an undefined slope. UND for undefined. It's not 0. 0 is horizontal. Okay, and that is up here, by the way. Horizontal lines have a slope of 0. Vertical lines have undefined slope. And I would hope this part goes without saying, but horizontal and vertical lines are perpendicular. So if we look at this and we know we have these 4 things that are perpendicular, what shape is that? It's a rectangle. If you're a rectangle, you are also a parallelogram. I'm not expecting you to write down quadrilateral because everything's a quadrilateral. Okay, next shape. W is at -1, 0, so that's left 1 and stay there. X is at 5, -4, so that is right 5, so 1, 2, 3, 4, 5, and down 4, which I should label these. So that was W, that's X. Y is at 3, -7, so right 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7. It's at the very bottom. And Z is at -3, so left 3, down 3. So -3, -3 is left down. That's Z. And what we have here is a diagram, 4-sided shape. I need my slopes. So to get from W to X, I go down 1, 2, 3, 4. And then I go right 1, 2, 3, 4, 5, 6. When I simplify, that is -2/3. For YX, I go up 1, 2, 3, turn and come right 2. For ZW, I go up 1, 2, 3, turn and come right 2. And for ZY, I go down 1, 2, 3, 4, and go to the right 1, 2, 3, 4, 5, 6. So down 4, right 6, which simplifies to -2/3. So what we have here, 3 halves and 3 halves, so WZ and YX are parallel. -2/3 and -2/3 are the same, so that means ZY and WX are parallel. So that's 2 sets of opposite parallel sides. You are definitely a parallelogram. Are you anything else? Well, we know those sides aren't the same, so it's not a rhombus and it's not a square. It could be a rectangle if these slopes are negative reciprocals. And they are. 2/3 and 3 halves are reciprocals. The 2/3 are negatives and the 3 halves are positive. So this is also a rectangle. This will not happen every time. You will, in your assignment and on the test, be presented with a diagram that only has 3 ordered pairs. It's a triangle. It's supposed to be. Your job is to prove that it's a right triangle, which means you will plot the 3 points, you will connect them, you will count off the slope for all 3 line segments, and you will show me that 2 of those 3 are negative reciprocals.